So as mentioned in the notes for week 0, we are going to be using Replit for all of our 210 labs. If you haven't already, make sure that you've joined the Replit team for this lab, because all of our lab exercises are going to be submitted and marked through Replit. So Replit is an online compiler. You can use it for C++, we could use it for many other languages. It has some advantages. It's going to be compatible with every device. It has cloud storage, but there's also going to be a few problems you should be aware of when you're using it. The first and most obvious one is since it's an online service, it is susceptible to network outages. So make sure if you're using Replit for assignments, you're keeping in mind that it might not work 5 minutes before the deadline. So you'll want to plan ahead around that. And another disadvantage of it is that by default, it will always try to compile from a file named main.cpp, which means if you're using another file that's not called main as your main file, you're going to have to do a little bit of extra work. And there's going to be two ways to get around that. And the first will be to just use command line control and just compile through the command line in Replit. And the second will be to set up a Replit configuration file. And to show you how to do both of these, we'll make a quick demonstration Replit. Go create a C++ Replit, and I can just name it something like demonstration. So when you open Replit, you'll have a screen that looks like this. You'll have your files on the left, your editor in the middle, and your console on the right, which will show your results of hitting run. On the far left, you also have a settings tab. You can use this to change your color theme, your layout, font size. It's good to change your indent size to 4. It'll default on 2. 2 isn't very noticeable. If we wanted to just do a quick sample program to show how this could work, we could copy this in and paste it here. When I click run, it will run this because it's named domain.cp with no problem. And just go through here. If this was not named main.cp, we may have to do command line G++. G++ being the new debugger, main, -o, and what we want our output to be named. This gives us an executable named hello, and we could run it like this. It would be a little tedious to have to write this every time we wanted to check our code. So what you can do is add a .replit file. And you'll be able to set it up so that you can configure what this run button does. So you enter the language and run equals, and then you'd put what we just wrote into the command line. When it runs, we want to call G++ on whatever file name we have, -o, and what we want our output to be. We can put a semicolon here, which will start a next command, and then we can have it run the output immediately. So when we click run, it will do this. It builds an output executable, and it runs the program. So that's how you can set up Replit for running different amounts of files. If you wanted to compile multiple files along with your main, we could try that out here. There's a few ways you can add files. There is just copy and paste add file. There's uploading files, or you can drag and drop the files onto the left. So this gives me an example with a new main, date.cpp, and date.h. To compile all of this together, I would go g++ main.cpp date.cpp minus o and the name of the output. And I can run it like this. So all I have to do to set up my run button to execute that command is go back to my .replit file and make it match. So date.cpp minus o, I'll name it date2, and run date2. And it just does this. It's up to you which method you use. If you prefer just writing into command line, feel free to do that. If you like setting up the .replit file, you can just do it like this. It's good to know how to do things in command line because sometimes you need to on other labs, but this is good enough for most of what we'll need to be doing. When we write our code, it's very seldom that we actually get our code to do what we want it to the first time we try. I'm sure most of us at some point have just wrote a cout or print line statements at every step of the code where something changes to see what's happening. And while that works, having to go back and remove every single printout statement that we put in at the end can be a little tedious, and sometimes we forget a few and it just looks a little funny. The better way to do it is to use a command line debugger, which Replit has one in beta. But before we talk about debugger, first we'll talk about the 3 types of errors you might run across as you're programming. The first is a syntax error, where you just have something written wrong and it will not compile, such as missing semicolons. The second is a semantic error, where your code is written properly, but at some point something goes horribly wrong and your program crashes. This often happens when you try to access a variable that wasn't given a value, or you try to open a file that doesn't exist. And the last is a logic error, where everything is running but you're not getting the result you expect. And I'm sure we've all had that one time where we put equals instead of equals equals in our control statement. That would be a logic error. So to use a debugger to find these errors, there's a few conditions you have to meet. First, your project cannot have any syntax errors. It has to be able to compile and link. Then you set what are called breakpoints along your code where you want to start watching the code. And then you use the debugger to step through line by line through these breakpoints to see what the values of your variables are as it goes down the code. So if we wanted to try that out with a file named debug.cpp, we could save that. And take it to the demo replit. I'm going to need to change this to use the debug.cpp. And we'll run it and see what happens. So this file is going to ask us for 5 numbers. And we'll see that those numbers were definitely not inserted into our array correctly. The debugger for Replit can be found on the left menu bar here. It is in beta, so there are a few problems. The most notable problem you may run into is if there's multiple CPP files with multiple main functions defined, it will get confused even if they're not involved in your run process. So to fix that, you can simply put a 2 right there as a temporary measure. Then we'll go to our debug.cpp file. We notice that our error seems to be when the values in the array were being assigned, which is happening here. So if we wanted to debug this and see what is going wrong, we could add a breakpoint at the top of our loop and at the cin of our loop, so that we'll be able to step through this and see what's happening. So once we have our breakpoint set, we go to our debugger and we click run. You cannot click the run up here. This just runs things normally. To use a debugger, you have to click this run. And once it loads the debugger, it'll ask you to enter your 5 numbers. It's not actually giving us the prompt for one yet, so we're going to click Next Step and start stepping through here so that it will actually prompt us for the value. So we'll enter the next number, we'll enter a 1. You need to make sure you're hitting enter here because this is hanging up on a CN. If you don't hit enter, it won't let you advance the debugger. And as we keep stepping through, we can see the values of our variables here. So at the point where it asks for the next number, we'll go 2. And then check our values array here. So at the moment, array 0 never seems to have got set, and the position for 1 got set to 2. If we keep stepping through, and go number 3. Position 1 got reset to 3, and none of our other positions are being set. That should give us a bit of an idea of what's going wrong here. So if we wanted to go a little faster, we could just skip to next breakpoint instead of having to step through every line. And finish through this loop. So we can still see that the values were all being set to 1, which means that our problem is in this assignment statement where this 1 should have been an I. And we'll be able to see that fix our program.